Hello class, today I'm going to teach you about parallelograms. You know what?
Does this mean I'm teaching?
Yep.
Guess I'm teaching. Let's get right on this. All right. Hello, subscribers. I want to update you guys on my number of subscribers. I currently have 9.
Right at you.
Right at you. Don't forget to click like. Okay. All right, so we are going to learn about parallelograms today. Super short notes. Oh, sorry. That was my daughter, by the way. Just trying to educate America. All right. Okay, so everybody have the sheet, front and back. We can start on our notes, our homework. Okay, so in review. It's fine, you can go under. Just don't hit it. Oh my gosh. All right. Any four-sided polygon is called quadrilateral. Okay. A segment joining any two non-consecutive vertices in a quadrilateral is called a diagonal. Okay. Here's an example of a diagonal. Okay. A special kind of quadrilateral in which both pairs of opposite sides are parallel is called a parallelogram. Heidi, can you stop, please? Because I want to make sure this is actually recording me. Okay. I'd like to check it. Can I check it? Do you guys mind if I wait? Check for a second? All right, write this down. Draw all the figures. Can you see? Is it recording me? Okay. Okay. All right. So these are theorems that all concern parallelograms. All right. Opposite sides of a parallelogram are, what does that mean? Okay, so how do I represent that on this figure here? Showing that opposite sides are congruent. Yep. I need to represent that these two sides are congruent. And these two sides are congruent, but they're different than those two. Good? Okay. Opposite angles of a parallelogram are congruent. Okay. So I need to represent the opposite angles are congruent, okay? So these two are the same as well, but they're different than the other two. Good? Consecutive angles in a parallelogram are supplementary. Kind of ran over that word. Okay. Consecutive, it's right next to each other. So this angle, actually, I'm going to draw some numbers in there. Does that feel like it? This angle is 60. The measure of this angle would then be 120. Right next to each other, consecutive. Same goes for these. That's 120. This has to be 60. 120. Okay? Consecutive angles. People are walking on the floor, crawling on the floor. Just so you know, subscribers. People are crawling on the floor. There goes Miss White. The diagonals of a parallelogram bisect each other. What does bisect mean? Exactly. Bi means two. Sect means cut. We're cutting whatever we're cutting in half. Okay, exactly in half. So the diagonals of a parallelogram bisect each other. So see how this diagonal is a little bit longer than the other diagonal? Those diagonals are not the same length, but they are cutting each other directly in half. So this length is the same measure as that length. And this length is the same measure as that length. Now you're going to learn later on in the chapter, we take those angles in a parallelogram and we make them right angles. Rectangle, those diagonals are going to end up being the same length. But that's later. You're doing a great job. Thanks. Can I move on? Sure. Okay. How's it going, Heidi? Are you learning anything?
No.
Okay. Okay, example. Try these examples. In the quadrilateral, if the quadrilateral in the figure is a parallelogram, find the value of x, y, and z. All right, since opposite angles of a parallelogram are okay, x should equal
65.
45 degrees, excellent. Since consecutive angles of a parallelogram are supplementary, y should equal
115.
because this angle is 65, so y has to be
115.
because 115 plus 65 adds up to 180. Okay, since opposite sides of a parallelogram are congruent, then z should equal
12.
How are we doing? Pretty basic, right? They get a little bit more complicated by, this would be like z plus 3. You said z plus 3 equal to 12. You solve for z. Okay. Here's how you can tell if your quadrilateral is a parallelogram. Okay? So these are tests for parallelograms. So you can show that a quadrilateral is a parallelogram if you can show that one of the following is true. If you have both pairs of opposite sides parallel, so I gotta show that somehow. How do I represent that two sides are parallel? What do I need to? Okay, so those two sides are parallel, and these two are parallel, but they're not parallel to the other ones, right? So I need to add an additional triangle there. All right, that means those two sides are parallel, and those two sides are parallel. But they're not parallel to each other. Different symbols. Both pairs of opposite sides are parallel. If you only have one pair of parallel sides, you end up with a, what's this called? Trapezoid, which we haven't learned about yet. Okay, but you guys have learned about it before. All right, so both pairs of opposite sides are congruent. Okay. You could also know that a pair of opposite sides are both, only one pair, are both congruent and parallel. And that's drawn here. I want you to draw the pictures. I want you to draw the pictures, subscribers. You might have to press pause. Do that. And where am I at? Okay, diagonals. The diagonals bisect each other. If you know the diagonals bisect each other, you've got yourself a parallelogram. So I drew a picture right here.
No, I'm not distracted.
Not distracting at all. Okay, and last information, you could have both pairs of opposite angles are congruent. Let me draw that. All right, if you know that both pairs of opposite angles are congruent, you've got yourself a parallelogram. How are we doing?
Good.
If you only have one pair of opposite angles are congruent, you could have a kite. You might not have a parallelogram. You need both pairs in order to be for sure that you have a parallelogram. We haven't learned about kites yet either, but that's coming. Can I go to the next slide?
Yes.
Was Benjamin Franklin and Hamilton at all?
Why are we talking about history?
Because he said Hamilton because
I said Benjamin Franklin.
The music.
Yeah.
Okay. What values of x and y must be, what values must x and y be in order for the quadrilateral to be a parallelogram? All right, keep on topping. That reminded me of a pie chart that I saw on Facebook. It was for teachers. It was like, and it had the different sections, and it said what students want to say when they raise their hand. And there was a very large shaded section. And it was like, can I go to the bathroom? Can I have a drink of water? It was like a question or comment unrelated to what they were doing.
You gotta love the teacher.
You gotta love it. Yes. Love teacher meetings. Okay. You guys should make me one. Put them up here. Okay. Have you done this yet? What values must x and y be in order for the quadrilateral to be a parallelogram? Since opposite sides of a parallelogram must be opposite sides. I don't like writing in red. A couple more examples to do. I just changed it. I think blue is easier to see anyway. All right, try this one. What value must x be in order for the quadrilateral to be a parallelogram? Since the diagonals of a parallelogram must, thank you, since the diagonals must bisect each other, this length should be the same as that length. How do we say these are the same in an equation? We set them equal to each other. See, I taught you guys something. Don't ever say I never taught you anything.
What?
I said that a lot at the beginning of the year. I said, how do we represent things are the same in an equation? It took you guys a really long time, but now you've got it. Equal sign.
Thank you.
Done. That's great. Okay. All right. Did we answer the question? We solved for x. The question is asking what value must x be. So we're done. Good. Name two things that you learned about parallelograms today. What? Opposite angles are congruent. Nice. Thank you. One more. Diagonals bisect each other. Done. Helving out. Right? We are done, right?
Yep. Yes.
Okay. Thanks, subscribers.
Hi.